Let's go back to reading of the general equation, some important information about the circle. We are looking at exercise 10.3, question number 2 from your textbook, and they are asking us to determine the center and the radius of each of the circles. On the first two, I think that is very, very simple. Because if I look at the answer for question A, my center of a circle must have the coordinates 1 and 3. Okay, because it's x minus a squared plus y minus b squared is equal to 16. So center is 1, 3, and the radius as square root of 16, which is obviously 4 units. So that's for answer A. For answer B, my equation is now x minus 2 squared plus y minus 0 squared equals to 20. So for question number B, what will be the coordinates of a center? Well, I hope that you said that the center has coordinates 2 and 0. What will be the radius of the circle? It's square root of 20, and if we are asked, and you need to be asked for it, if you are asked to do it in a simplest third form, it will be 4 times 5 under a square root, so 2 square roots of 5 would be the simplest third form for the radius. So question A, I hope that you agree, and question B were very simple to determine the equation, to determine the radius of a circle and to state the coordinates of a center. What about number C? What's the problem with C? Okay, the problem with C is that our equation is not in a standard form. It's not in the form x minus a squared plus y minus b squared equals to r squared. I can state the coordinates of a center and the value of the radius of a circle only if my circle is in this form. If it is not, and that's as in your examples from C to J, if it's not, you have to rewrite it to the standard form. And rewriting it to the standard form will mean for us to complete the square. Let's look at the method of completing the square for some of the questions from exercise number 2. Look at question C first. In order to create a 2 perfect square trinomials, one in x and one with y, I must group everything that has x in it and everything that has a y in it together, and I must take all my constant to the other side. So I'm taking minus 24 to the other side. Okay, so y squared is done. That's my perfect square. Obviously I can see that therefore the y coordinate of a center in this example will be 0, but I still need to figure out the x coordinate. To do that, we need to look at this first 2 terms given. Right, these 2 terms, if I want to place them into a bracket with a perfect square, I know that I will have x as a first because x squared will give me the first term. If I'm multiplying out, then this minus must remain the minus. And in order to get the 2x, I will have to take that coefficient of the x and divide this by 2. Will it work? If I multiply this bracket out, okay, my bracket is x minus 1 squared. What do I get? X squared, great, I have my x squared, minus 2x, great, I needed a 2x, but there is the 1 that I did not have. on the left-hand side of my equation. So what must I do in order to balance my equation? If I created a +1 on the left-hand side, I will have to add 1 to the right-hand side of my equation. Let's look at this equation, question number C, once again. Right, let's look again at our organized trinomials. So I have x squared minus 2x. From here, I will have to create a perfect square trinomial that fits into my bracket x with a square. I had plus y squared, so that wasn't a problem, and then I took my constant to the other side and had plus 24 in there. Okay, so now let's talk about this perfect square trinomial of mine. How do I get a second term here? Well, you saw this as we were expanding. If there is a minus in front of the coefficient of x in a first step, then there will have to be a minus in the coefficient in a second step. How to get this term then? Right, that's where you take the coefficient of x. Now you ignore the minus, you take that coefficient and you have to divide this by 2. Okay, but you then know that what sits inside the bracket here, in this bracket sits a trinomial. It's x squared minus 2x plus 1. So I've created the extra 1. So in order to balance my equation, I must add 1 to the other side as well. Okay, so now my equation is x minus 1 squared plus y squared is equal to 25. Now I can make a statement about the coordinates of a center as well as the radius of the circle. So what are the coordinates of a center? The coordinates of a center are x coordinate 1, y coordinate 0, and the radius is square root of 25, which you don't have to write as long as you write that the radius is 5 or the radius is 5 units. There are two ways of writing out the step here when you complete the square. Some of you will like to write first the perfect square trinomial and then create a bracket, the perfect square. Some of you will be able to skip this step and go directly to our perfect square trinomial fully factorized, which means to the bracket. So I'm going to do one more example using both steps, and then you can choose which one you want to use for the future examples. So let's look at questions number E and F from the same exercise. You have to determine the equation, not the equation of a circle, but the value of a radius of a circle and the coordinates of a center. How we do it? We need to write our circle in the standard form, x minus a squared plus y minus b squared equals to an r squared, and to do it we need to complete the square. So let's group it as we did it in a first example. I have x squared plus 2x. I have my y squared and I take a constant to the other side. So the first method of doing it would be to take the first two terms and to recreate the perfect square trinomial. So if the first term of a trinomial is x squared and the second term of the trinomial 2x, then the third term of the trinomial will be the coefficient of that x divided by 2 squared. Okay, because I need to get perfect square trinomial. plus y square equals to 12. But I cannot leave it just 12 because remember I've added this term in here, which is 1 square, so I need to add that 1 square to the other side. Now this 3 I can group as x plus 1 square, okay, that's my perfect square trinomial, plus y square equals now 13, which means that the center of my circle in this example has coordinates -1 and 0 and the radius of square root of 13 units. You can write units, you don't have to. Okay, so you either show this step or you go from this step directly to this one, showing this part, showing how you got to the 13. So you have to say 12 plus 1. Let's look at example number F. Okay, so let's group it. Now this one is a bit more complex. I have x squared and 2x, but I also have y squared and 4y equals to 31. So I have to recreate a perfect square trinomial here and perfect square trinomial in y. Okay, so perfect square trinomial in x. This will be x squared minus 2x plus, always plus, because that's a square, so it's a coefficient in front of that x, divided by 2 square. Okay, if you want to write minus, it's also fine, but it will be plus the square of minus 2 over 2. Okay, then with the value of y, we've got y squared plus 4y plus, okay, 4 over 2 squared, which is then equal to not 31. Okay, it's 31 plus this extra term that I added, which is minus 1 squared, which is 1, and this term that I added extra, and 4 over 2 is 2 squared, so I'm adding a 4 also. So I get the following equation. I get x minus 1 squared plus y. Now this, remember, here 4 over 2 was a 2, so it's plus 2 squared, and that's equal to 36. So in this example, the center of a circle has coordinates 1 and minus 2, and the radius square root of 36, so it is 6 units. Pause it, analyze it, think about it, see if you understand how to complete the square to find the center and the radius of a circle. The last example is example J. It's slightly different to the other examples because you will notice that the coefficient of x squared and the coefficient of y squared is not 1. However, the coefficient is the same, and that's very important. If the coefficient doesn't have to be 1, but as long as it's the same, we can always divide both sides by this common coefficient. If it's not the same, then it's not a circle and we cannot analyze it. So what do we get if we divide everything by 3 and we group it to prepare our equation so we can start looking for the center of a circle? So 3x squared divided by 3, I get x squared. I will also have a 6x here. 6x divided by 3 is 2x. Then I have 3y squared divided by 3, so I will get my y squared, and then 9y divided by 3, I get 3y, What do we do with 6? Well, we will take it to the other side, but we're dividing everything by 3, so it will be minus 2. Right, so now I'm going to skip the step in which you can show the trinomial, perfect square trinomial. I'm going directly to my bracket. So I will have a bracket with the x squared, and I will have a bracket with the y squared. Okay, this will be equal to minus 2, and I will have to balance my equations. So if I'm looking at my x, the plus remains a plus. Now this coefficient, the 2, must be divided by 2. But what I must do immediately, I must add the results of this division, which is 1, square to the other side, because that will come up in my trinomial. If you don't see it, please first create your trinomials. Now with the value of y, I have a y plus stays a plus. Then I take this number, the coefficient of y, divide by 2. And what I do, to the other side, I immediately add 3 over 2. 3 over 2 squared. Okay, we add 3 over 2 squared immediately to balance it. Let's simplify our equation. So I have x plus 1 squared plus y plus 3 over 2 squared. And here we've got minus 2 plus 1, which is minus 1, plus 9 over 4. So we get on this side 5 over 4, which means that the center of my circle has coordinates minus 1 and minus 3 over 2, and it has a radius of square root of 5 over 4, which is square root of 5 over 2 in the simplified form. Okay, boys, please play again. Watch it over, find your way. See whether you need to write the trinomial first, or you understand this step when I omit writing the trinomials, but write already in a factorized form, and I don't forget adding the correct values to balance my equation. You will be asked to practice completing the square in order to find the coordinates of a center and the radius of a circle in your homework activities. Good luck.